Hello, algebra students. Mr. Lawrence here, and here's a quick video on the worksheet 7.5, trying to figure out how many solutions a system has. Now, the key here is all about slope. Okay, remember the systems we're dealing with are linear systems, and they only have two equations. Right? A system could have an infinite number of equations. I think I mentioned in class that I had to solve a system once in grad school which had 41 equations. Okay, now I had the help of a computer because that would be very tedious to do by hand. But anyway, so we're looking for the place where they intersect, right? These two lines, like system number one here, these two lines, they're going to cross somewhere. Or maybe they won't cross. The key is the slope. First thing I want to do, and it's smart to do before you solve by substitution, if you check the slopes, it will give you some very important information. So let's do that. Okay, so on number one here, I'm going to check the slope. And I know the slope of the first equation, I'll put m sub 1 for the first equation, the top equation, is going to be 2 because I'm in slope-intercept form. And then the slope for the bottom equation, or the second equation, is 3. What does this tell me? This tells me that the lines will cross each other because they have different slopes. So if the slopes are different, I'm guaranteed that there will be one solution. One solution. Now, you might be thinking, what is that solution? Well, to find it, we have three choices. We could go ahead and use substitution, elimination, or graphing. And you're like, oh, they're both in slope-intercept form. Let's graph. Well, sometimes that's a good idea and sometimes it's not. We can't really tell where they're going to cross. And so we don't know if the intersection, the coordinates of the intersection, will be whole numbers or natural numbers, integers, or will they be rational numbers, some ugly decimals, or conceivably even irrational numbers, okay? So if I'm going to solve this one, I think I'm going to go with substitution because I already have y by itself. Y is the same as 2x minus 5. So I'm going to go over this other equation, and I'm going to substitute in. I'm going to go 2x minus 5. I don't need the parentheses because that y here is isolated. It's all by itself. If I had anything by it, I would put this in parentheses. All right, so I'm going to get equals 3x plus 5. And so I'm going to subtract 2x from both sides, right? And while I'm at it, I might as well subtract 5 from both sides. I'm going to end up doing it anyway. All right, and so then, get more page here. Some more page. I'm going to get negative 10 is equal to x. And so now I know the x coordinate, and it doesn't matter which y coordinate I use. See, y equals 2x minus 5. So I'll use that one. Y equals 2 times x minus 5, right? So I'm going to get y is equal to negative 20 minus 5, which is negative 25. So I'm guaranteeing you, unless I've made some kind of error, I don't think I have, that these will cross at the point negative 10, negative 25. Let's go ahead and check it here. Let's see. Let me get, yeah, there's the worksheet. Let me get Desmos open. Since I know they're going to cross at an intersection where the coordinates are both integers, y equals, was it 2x plus 5, and then the other equation was y equals 3x minus 5. No, I must have those backwards. Let me check real quick. 2x minus 5 and 3x plus 5. So, all right, so let me change that to a minus and that to a plus. And then I can't see them cross. I'm going to zoom out. I'm going to scroll and look at that. Look where they're crossing. At negative 10, negative 25. So it would have been okay to graph. Graphing the negative 25 could have been a bit of a pain, but it would have worked. Okay, so I tested the slopes, found that they were different, and that tells me there's one solution. Okay, and I'm pretty sure I gave you a flow chart on this, but you can ask for another copy, or maybe we can reproduce one, or if you need some help. Okay, so check the slopes. If they're the same, we know there's one solution. Then we use either graphing, substitution, or elimination to go ahead and find it. Okay, so let's look at problem number 2. So let's check the slopes. So the slope of the top equation is 3/4, and the slope of the bottom equation is 3/4. Okay, this time the slopes are the same. Now that leaves two possibilities. Either the lines are going to be parallel, like we learned way back in chapter 5, or they might be the same line. If they're parallel, we'll have infinitely many solutions. No, excuse me, if they're parallel, we'll have no solution because the lines will not cross in our flat land that we exist in Algebra 1. Okay? If the lines are the same line, they will intersect in effect everywhere, and therefore there would be infinitely many solutions. Any value we put in will work. So let's see here. How do we know which one's which? Well, let's check the y-intercepts. I know the y-intercept of the second equation is pretty obvious. That's 0, -2, right? The y-intercept of the top equation is going to be 0, -3. Since they have the same slopes, but they go through the y-axis in different places, they must be different lines, and therefore they're parallel. 3x minus 4y equals 12. Let's go back to Desmos and check. And so this time I'm going to have 3x minus 4y equals 12. And what is it? Y equals 3/4 x, what was it, -2? And then hit the home, and look at that. They sure look parallel, and there's the y-intercept of the one equation and the y-intercept of the other equation, just like we had figured out. So now we know if the slopes are different, there's one solution, and we'll solve either using graphing, substitution, or elimination. We also know that if the slopes are the same, we need to check another point, the y-intercept. You could check the x-intercept too, or if it was in points, if both equations were in point slope form, you could check that point and see if it's the same point, okay? So if the slopes are the same and the other point, the intercept, the y-intercept, are different, then there's no solution because the lines are parallel. All right, let's look at this last one here. So let's see, we'll check the slopes, right? So the slope of the top one is -2. And the slope of the second equation, the bottom one, is -4/2, which is -2. So we've got the slopes the same. Cool, they're parallel. Hold your horses. The y-intercept of the top equation is 1. The y-intercept of the second equation, using my standard form shortcuts, is 1. These have the same slope and the same y-intercept. They're the same line. This has infinitely many solutions. Infinitely many. And again, we can go to Desmos, and I can show that to you. So let's see here. What are we going to get? Y equals 2x. Can't remember, was it +1? No, I think it was -1. Let's see. Nope, it was +1. It was -2x and a +1. So let's fix that. So we're going to need a negative there, excuse me, and a positive there. Okay, the next equation is going to be 4x plus 2y equals 2. So we're going to go get 4x plus 2y, that's going to equal 2. And look at that. You only see one line, don't you? Yeah, there's only one line there. Now they're showing 2 points, but right now the blue line is highlighted. Let's do the red line. I'm going to click in the box over here where the red line is, and look at that. It changed color, but nothing else changed. The y-intercept's the same, the x-intercept is the same. See? The y-intercept is the same, the x-intercept is the same. Okay, so that's the gist of that worksheet 7.5. How many solutions does a system have? Well, you check the slopes. If they're different, there's one solution. You can find it using substitution, elimination, or graphing. Sometimes graphing is not the best choice, but we've talked about that before. If the slopes are the same, we need to check maybe the x-intercepts, maybe the y-intercepts, maybe another point. If that other point or that intercept is different, slopes are the same, y-intercepts are different, slopes are the same, x-intercepts are different, then the lines are parallel and there will be zero solutions. The lines will not cross, and that's what a solution is, the place where the lines cross. And finally, the third possibility is the slopes are the same and that other point is the same. Slope's the same, x-intercept's the same. Slope's the same, y-intercept's the same. Then we have the same line graphed on top of itself. And so they're going to intersect everywhere, and therefore there are infinitely many solutions. Now, if you're getting ready to solve a system, it's a very, very smart idea to check the slopes and check the intercepts ahead of time. One, if the slopes are different, you know there's one solution. If the slopes are the same, you know either there's no solution or there are infinitely many solutions, and you can determine that pretty quick without having to do all the algebra. Two, if you're asked to solve one by graphing, there's a chance that the two systems might intersect at one of the intercepts. If they do, you find them first, you're going to know the solution to the system before you actually do the graphing. So just some things I think will help you out. All right, that's it for the video. If you need another one, today is a very good day. Today being Saturday, Sunday is very busy. However, it's my birthday and there's a lot of things going on, so I won't have as much time. Okay, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.